Here we're asked to graph the equation given. We're going to state the locations of the intercepts, and we're going to use a graphing calculator to check and talk about when it's increasing and describe the concavity. So we'll start by sketching it here. So when we're dealing with this problem here, I'm first going to factor everything as much as possible. So 0.2x is kind of like what we'll call my first term here. X squared minus 1 is a difference of squares, so x plus 1 and x minus 1 is what it breaks up into. I'm also going to factor this here, which if you need practice on your factoring, please do so, but I'm not going to go through it in this video. This should be x plus 4 and x minus 3. So when we are doing this, we have a couple of different pieces that we need to understand. So I'm going to plot all my x-intercepts, which in this one are 0, -1, 1, -4, and +3. So 1, 2, 3, 4, -1, 0, 1, and then +3. And so as we go through this, a couple of things happen on this graph here. So it's a positive value, so it's going to be going up here, down, up, down, and up. And that's kind of the general shape of it. Now, the 0.2 here, some people are like, what does the 0.2 do in this graph? Well, it really is going to be shrinking our graph down. Instead of having like this like super exaggerated graph that looks like this, the 0.2 shrinks it down a little bit to make it a little bit more manageable. If we were to look at the extrema, state the locations of the extrema, well, basically, I'm going to focus on a couple of them. I'll mostly look at this one here. Actually, let's change colors in purple here. These are the two extrema I'm going to actually go through, but extrema just means like local minimums and maximums. So we could really even do like these two if we wanted, but just for sake of time, I'm going to focus on these ones here because I'm basically just going to be plugging it into a calculator anyways. So when I'm doing this, I guess I should talk about the intercepts here. So the nice part is that the y-intercept is at the origin here. So y-intercept is at x equals 0, or y equals 0, I guess. It doesn't really matter. The coordinate 0, 0. And then the x-intercepts, there's a lot of them. There's 5. Well, one of them is 0, 0. Then we kind of went through them already. So -1, 0, 1, 0, -4, 0, and 3, 0. So 5 intercepts for the x-axis. And then my extrema, again, I'm focusing specifically on the local maximum up here and the local minimum here. They're not global maximums or minimums because these graphs go on forever up and down. So basically when I plug this into my calculator, I can find the maximum values at certain points. And this becomes like a y value of about like 29.39. And this y value becomes like -8.78. So these are some extrema, meaning like some high points and some low points. If we're talking about where it's increasing and decreasing, well, I will highlight everything in green where it is increasing. Here it's increasing, here it's increasing, and here it's increasing. I could write that out as a interval if I wanted to. I could say, -infinity up to, it's some weird x value, not specific. Again, I could find it in my calculator if I wanted to, but really I'm just going to kind of estimate it as like -2.5. I'm just being lazy here. You could find it specifically on a calculator. I'm just not super picky about that at the moment. Same thing with this one here. I would go from like -0.5. I'm super rounding on this to +0.5. And then the last interval would be like 2-ish to infinity. As far as decreasing goes, if I look over here, it's decreasing where I'm going to highlight in orange here. And basically it's just those in-between values. So if you notice from negative 2.5 to negative 0.5, and from like 0.5 to 2. So really these values should match, because where it's not increasing, that's where it's decreasing. Last thing with concavity here, so concave down, it's going to be concave down for a lot of it. In the beginning here, I'm going to highlight in yellow. And then at a certain point in brown here, it becomes concave up, then turns around and becomes concave down again. And then back to brown, concave up for the rest of that there. So maybe tough to see. I guess I should do, we'll go concave down as in, oh, that's so bad. It changes it to purple. Dang it, I was trying to make things easier. Okay, I will erase some of this highlight to try and help. Oh no, my graph. This is chaos. Okay, so brown is my concave up. Again, we'll go yellow is concave down, and concave up. So again, we have these intervals that we could find on a calculator, but basically we just need to be able to see when it's concave down and concave up.